Hello everybody, and welcome to Ciencia, compartida. Today we have Jennifer Purcell with us, which is a honor. She is a researcher from the Western Washington University, and she will talk to us about jellyfish blooms around the world. And without further ado, let's welcome her with a round of applause.
Well, it's fun to be able. Can everybody hear me? If you can't, wave or something. And also, if I don't speak Spanish well enough to give a talk in Spanish, so you'll all be grateful that I'm not going to try. But if you don't understand something I say in English, please say, to do. I've written a lot on the board, so the slides will have a lot of words that you can help you understand, perhaps, if I don't understand it, speak too clearly. It's fun for me to be here in the Canaries with Mai and Ted working on, and Danny and Vanessa and all the group there, working on to learn enzymatic methods for the study of jellyfish ecology. But I don't know enough about that yet to have any results. So I'm not going to talk about that today. But what I will give is an introduction to all of you who may not have had much exposure to what jellyfish are about. So I'm going to give an introduction to that, and hope you enjoy it. This is the background picture is jellyfish, in case you didn't realize that. Okay, so the first thing I'll talk about is the diversity and life cycles and things of jellyfish. Many people don't realize how many kinds of jellyfish there are. They can see big ones off the docks or when they're swimming or from a boat. But these bigger jellyfish, which can be, really quite large, but a third of a meter or something, there are about 200 of those species. So there's a lot of different kinds of them, and so there are a lot. And all of these jellyfish that I'll be talking about today sting. So they most people don't like them very well because they do sting. But all of them are going to sting to feed, and people that bump into them get stung by accident. Now, there's another large group of jellyfish that are very small and go unnoticed. Is it possible to turn out the lights a little bit more? Or dim the lights? Oh, thank you. That's good. These jellyfish are only about a centimeter in size. Most of them, some of them are even smaller than that. And this one, I'm not sure I can point. This is. Does that work? No. All right. This one is actually very large for Hydra medusa. But there are 800 species, there are more than 800 species of these smaller jellyfish that nobody notices because most of them are so small that they don't even know that they're not even seen. And the hydroids that live on docks and plants and the rocks and things like that, those are what produce these little hydromedusae. So I'll be using these terms now and again, so hopefully you'll understand that there's big ones, which are the Siphomedusae, and then the little ones that are the Hydromedusae. Sure. Now I can't see mine. There we go. No, that's the wrong one. All right, there we go. And then there's another group of jellyfish called the Cubomedusae, and I don't know if they occur around here, but Mai's shaking her head. They are mostly, Australia is famous for them, and they can kill a human in about 2 minutes. So they're very, very deadly, and there's another, a very small one of this box jellyfish group that causes something called Irukandji syndrome that is killing people as well. But those jellyfish are so small that people don't notice them very, very much, and the results, the stings, or have bad consequences afterwards. But these things are very, very deadly, and you want to be very careful about them when you are in the water. But one of the things that most people don't know anything about is that the jellyfish that I've been talking about have stages that live attached to surfaces. So this is a life cycle of a moon jellyfish, which is found around the world more or less. And they start out with this polyp. Is this a pointer?
No, this is
But that's the recorder? Okay, I'm sorry, okay. No pointer. Anyway, they have this little polyp that is attached to the bottom. Sorry, not the bottom necessarily. They really do well by living on marinas and floats and things like that. They like to be upside down. So these polyps they're only about 1 millimeter in size, 1 millimeter or 2 in size, and they can produce other polyps. And then they undergo a process of division that then they just break off like little discs, little umbrellas. They look like little snowflakes, and they're about 1 millimeter in size, so they're really very small. Can't see them at all, but they grow quite quickly into the adult jellyfish that are sexually reproducing. So this is asexual reproduction, and these polyps can make big colonies. So here's a picture of a polyp that is undergoing this strobylation, the division process, and this is one of the little babies called an ephyra. So it will then grow up to the adult jellyfish that is sexually reproductive. The eggs and sperm form a larva that then settles on surface again. So the life cycle of the hydroids is more or less the same. Okay, this is a moon jellyfish thank you. Let's see if I can do this without blinding somebody in the audience. This is the moon jellyfish that I worked with in Washington State, which is where my home state, and we were taking photographs. A graduate student was taking photographs. So this field of view is 5 centimeters by 7 centimeters, and in 1 month, in January, this is the number of polyps that were there, and they were all white. So they weren't reproducing at that time. But a month later, they had all begun to undergo this process of strobylation to produce the little jellyfish, which you can see. I'm going to try this. I don't know where to push it. Anyway, these, you can see, people in front undoubtedly can see the little discs. So each of these little baby jellyfishes is orange, giving them an orange cast. And you can see that there are a lot of jellyfish being produced from a 5 by 7 centimeter area. So you can kind of imagine how many would be produced. Okay. Okay. All right. Okay. Go back. Okay. Anyway, my graduate student went and underneath these polyps were all living on a dock or in a marina, and he estimated the coverage of all the polyps in that marina. And from the information we gathered from these slides, we estimated that nearly 1 billion jellyfish would be produced from that one marina. So you can imagine how many jellyfish are being produced in an area. Okay, now how many of you have been walking on the beach lately? Have you seen these animals? The Portuguese man of war, yeah, the carabella, is that right? I counted 10 on the beach this morning when I was walking. They are actually, it's another group of it's not a true jellyfish. It's related to the hydromedusae, but it has a gas float, and this is the only siphonophore that has a gas float at the surface. And then below the gas float is the tentacles that hang down, and they sting very badly. They sting nearly as badly as the box jellyfish. And they're massive, they're very strong and large compared with a lot of the jellyfish. So they deliver a very bad sting. And I studied a relative of it that is found, it's more string-like and it occurs underneath the water. But you can see the little shiny dots that are occurring. Each one of those is a stomach. So each of the stomach has a little shiny dot. And so when I was studying my PhD, I was studying the feeding of these animals. And I found that those little shiny dots were what remained of the eye pigment of fish larvae. So all of this animal, this species, was only eating fish larvae, which was really amazing. And so that made me very interested in what other animals, like the Portuguese man of war in its group, was eating. And so I studied that too, and they only eat soft-bodied prey as well, most of which are fish larvae, and things like squid larvae and other soft-bodied things. So this whole group of siphonophores is very specialized to eat fish, which is amazing to me. Oops, sorry. I must have hit 2 buttons at once. These siphonophores are considered to be colonial, which is kind of weird, but they function as one animal. But there are over 200 species of them. Okay, now I've been talking about stinging animals, but these are also, they eat little animals as well. All of them are eating small animals that live in the water. And these are called comb jellies or ctenophores. So there are about 200 species of them, at least 200 that have been described. They're very difficult to study because they're very delicate. And most of them can't even be preserved or captured in a net, so that most of them haven't been studied well at all. This one is called a sea gooseberry, and it does preserve in plankton samples, but that's one of the only ones that does. This one is become famous because it has been introduced around Europe, the Nemiopsis, and it's ravaged the Black Sea, and it's up into Norway and all through northern Europe. So I don't know, you probably don't have it here yet, but it's a very fierce predator on things, and you can see it, the fun thing about these animals, they're really beautiful, but they're very, very, very transparent, and you can see right through it. So right now you're seeing its gut, stomach, with little tiny copepods inside there. So each of the little spots there in its stomach is a copepod of about 1 millimeter or so in size. So all of these animals would be eating something like that. And the comb jellies are very photogenic, and photographers love them because they refract the light from the strobes of the cameras, so that they look very beautiful and rainbow-like. But they are moving through the water. Unlike the jellyfish, I think most everybody is familiar with how jellyfish swim through the water and move the water through their tentacles. But these have the comb rows are what they use for locomotion. So they move them in a gliding pattern very smoothly through the water. This is like, I think of it as a giant vacuum cleaner. It swims mouth first, and everything that comes in this direction then can hit one of these lobes and be captured. So it's just like a vacuum cleaner. It goes through the water and gets everything that's in its way. These, on the other hand, are they swim with their comb rows and then set the tentacles out so that they're more like a spider in the water that isn't swimming while it's feeding, but it has this net of branched tentacles that are out in the water. So they have a wide diversity of feeding arrangements, as you can see, and you might imagine that they have different feeding habits as well, and they do, but I won't go into that today. Okay, now the only reason that people care about jellyfish, really, besides the fact that they're beautiful and all, is that they're causing a lot of problems for humans. So I'm going to talk a lot about that. That's the human perspective on things because they're bothering humans. But one of the things that jellyfish do, again, that people don't know a lot about, the general public don't know much about, is that they're eating the same foods of the jelly. So all of these animals I've talked about are eating these little zooplankton prey. So here we have a copepod, which is what was inside the Nemiopsis gut. Some smaller ones here, but these are just small animal plankton that are through the water column and only very, very small in size. You wouldn't see them when you're out there swimming so much. But these jellyfish can remove virtually everything from the water. So this is a picture from Japan taking a plankton toe in the middle of a jellyfish bloom. So this is one of those moon jellyfish aggregations. And what they measured, this net is small enough not to catch too many jellyfish, and it hopefully catches whatever's left in the water that the jellyfish haven't eaten. So this is inside the jellyfish group, and this is outside the jellyfish group. So you can see that the jellyfish have basically removed all of the food from the water. Now, if you're a fish that wants to eat the zooplankton, which many fish do eat zooplankton, you're out of luck. So here are some of the schooling fishes that eat the zooplankton, and they're very important in the trophic web of the ocean, and also food for people and food for aquaculture fish and things like that. So all of these schooling fish are eating zooplankton as their main foods when they are adults. But all of the fish larvae, the baby fish of all species, eat the zooplankton as well. So the jellyfish are possibly competing with all of these animals that then provide food up the food chain. Jellyfish are also important predators of the young eggs, or the eggs and larvae, the young fish. So this is one of the jellyfish, the crystal jellyfish I showed you before, that is a large jellyfish. This is probably 5 centimeters in diameter or so. So it's catching prey with its tentacles and ingest and swallowing it here at the mouth and then digesting it up here in the middle. But I had an opportunity to study it for several years over, is it possible to move the camera a little bit? We're missing the end of the, no? Okay. Anyway, over at this edge, you can see the 5, and that's, the jellyfish were very abundant. So this was 5 jellyfish per cubic meter in this case. They're more commonly not that many of them, but as the jellyfish became more abundant, they were removing an increasing proportion of the herring larvae, the baby herring that were living in this one bay. So this jellyfish is a very important predator of fish eggs and fish larvae. It had eggs and larvae of 7 families of fish in this area that I was studying. And I was focused on herring, but it really is an important jellyfish, in my opinion. Then we're still talking about problems for humans. I mean, the humans don't want, I mean, it's a problem for fish too, but it's a problem for humans because the jellyfish then are removing things that the humans would want to eat themselves. And the humans are trying to catch the fish as well. But here we have some of the fishing trying to take place when there's a bloom of this moon jellies. And you can kind of imagine, you can see them falling all over the net. So all of these white globs are jellyfish, the moon jellies. And this is the fish catch, which is mostly jellyfish, just a few fish. So you can see that this is a huge problem for the Japanese fishermen, but this is happening all around the world. So I'm just giving you an example. Another problem that jellyfish cause humans is that they can kill the fish in fish pens, the aquaculture fish. And this is one of the jellyfish that occurs around here. It's a bad stinger. The Mediterranean has been having lots of problems with it too. The tourists really don't like this one. But it comes up the coast of North America and apparently down here as well. But it can get blown in and transported into the Irish and Scottish fish farms. So it goes around Northern Europe and then can basically wipe out all the salmon that they're trying to raise in the fish pens. So this is, again, something that's happening around the world. There are various jellyfish that are causing these kinds of problems, and they bump into the fish nets. The tentacles break up. Some of the things that live on the fish farm actually produce little jellyfish and that can go inside the pens, which the fish then inhale into their gill chambers, and it basically suffocates the fish in there. So this is a huge problem for the aquaculture, which they're only starting to acknowledge, and people are only starting to study it because, you know, the aquaculture people don't want to admit that they have problems. So, and they don't want to let information like that out. So it's been very hard. Only when the problem becomes very serious are they willing to share information with scientists. Another problem for humans is that the jellyfish sting. And this means that you have to wear protective gear when you're fishing and things like that. So this is awkward, and most everybody is aware of being, of jellyfish stinging, and nobody likes it. Everybody wants to avoid it. Has anybody here been stung by a jellyfish? Yeah. Okay. Do you remember it? Yeah, you remember it? Okay. Yeah. I don't think anybody's stung by a jellyfish and forgets about it. It's a big problem. Tourism is a big business in the waters that are warm, and it's a big issue. Okay, now humans again want to know: are the jellyfish blooms increasing? And people would argue there, amongst even the jellyfish biologists, there are arguments about that. But in fact, there are blooms all over the world. Up in, let's see, where are we? Not so much off of where you are, but in the Mediterranean, they've had big problems. Off South Africa, Libya, they have big problems. Asia has had big problems. Black Sea has basically lost its fishery. North Sea has had huge problems. So there, and the Gulf of Mexico, there are blooms of jellyfish everywhere, and it's really causing more and more problems around the world. And most of these problems are where people have high populations. This is data that I compiled from Japan that they started having problems before anybody else did. They have very high population. They use their inland sea very extensively. So they started to have problems with the moon jellyfish back in the 1920s. So I've added up data from by decade through the 2000s, and the typical problems, the major problems that jellyfish cause humans are in fisheries, that they're clogging the nets, or they sting people at the beaches, and then they also can clog the power stations. So this is they come into the inlets of power stations and they clog them. And this is something that's also happening around the world. Desalination plants are also a place that they could block. So it seems to me that the number of problems have really increased over time with the jellyfish in Japan. And I think that there are a lot of countries that would agree that that is happening. This is, I should point out too, this is a jellyfish that Japan is having big problems with now. And that's not a trick photograph. That jellyfish is that big. And they can actually outweigh humans and be bigger. So this is a big jellyfish that's causing big problems in Japan. It's not part of these problems so much. It's mostly the moon jellyfish that's causing these problems for them. But so if jellyfish are increasing, what's the possible causes of these changes? And it's very hard to sort this out. There are things you can do. We've done some experiments, but they're all interacting. All of these things are happening at the same time. So it's hard to say, okay, well, it's one thing or another. But what we see is that there are, the climate is changing, as almost everybody except my president agrees with. He's not my president, by the way. I meant to wear my button, but I forgot today. Ted and I don't believe in him as our president. But the correlations with warm ocean temperatures, so the temperatures are going up, and then the warmer temperatures directly affect the jellyfish growth and reproduction. So here we are back at with the giant jellyfish that are coming up from China. The Chinese don't like to be blamed for this problem that Japan is having, but actually it is their fault. The jellyfish are coming from the Yangtze River Valley, and they are produced there. Many of the jellyfish also stay in the Yellow Sea of China, but when the conditions are right, they go up into the Japan Sea, which is right along in here. And so one of my colleagues in Japan, Sunichi Ue, has been studying these along the coast of Japan. And so these red and blue dots are where these giant jellyfish that can weigh up to 200 kilograms have entered the nets of fishermen. And the Japanese fishermen set up these gigantic nets. They're 2 kilometers long. They're called set nets, and they leave them in the water. Each of the net costs many millions of dollars. But they're designed so that the fish swim in and then can't get out. Well, that happens to the jellyfish as well. And so you can imagine what happens. It's a huge problem if you've got a 2 kilometers long net with full of these gigantic jellyfish. So they've worked out some clever solutions to that. But you can see that these jellyfish are getting up all throughout the Japanese coastal waters, and actually go around to the Pacific side. So it's been a huge problem for Japan. Oops, what did I do? Wrong button. Okay. Okay, still with the giant jellyfish. They have had blooms as well in the past, and the first bloom that they noticed was in 1920, and the second bloom that they noticed was in 1958, and which isn't very often. But look at in the 2000s, they've had blooms almost every year. So you get these giant jellyfish that are coming up along the coast, filling the fishermen's nets almost annually in the 2000s. So it's a terrible problem, and they're correlated. I mean, these blooms, you see that the temperature is going up, and the nutrients are going up. But you can't, so those are just correlations. It might happen. It might be a cause. It might not. So I've done experiments with some of these moon jellyfish. Remember the ones that were growing under the dock in the marina? I was doing experiments with them at different temperatures and different salinities. And remember that I mentioned that the little polyps can produce buds, and they can also produce the little jellyfish. So when you have warmer temperatures, oops, sorry, I should have changed that into centigrade. Mm-hmm. I did. I changed it. That's not correct. That's not right. Okay, I got to go back and fix that. Yeah, no, I changed. Sorry, I normally have things in centigrade for my scientific presentations, and this was changed for a public presentation. So I've got to go back to my science slide. I apologize. So anyway, this is Fahrenheit, which you don't relate to. Anyway, this is about 7 degrees, I think, and this is about 10, and this is about 15 centigrade. And as the temperature goes up, they're producing a lot more jellyfish. So they don't produce a whole lot more in the way of polyps, but they certainly do produce more jellyfish. So it looks like if they're producing, if the temperatures are going up, they will produce more jellyfish. And you can see that the temperatures are going up. What scares me most is that, you know, I've paid attention to this climate warming information, and they have models that predict more or less what they expect what will happen. And they give the worst case scenario and the best case scenario and the average scenario. But what's actually happening is worse than the models. And so this is all happening faster than even the worst predictions. But there's no doubt that the water's warming, the oceans are warming, and it will continue to go up. And another problem in the ocean is that the waters are becoming more acidic due to all the carbon in the air. And one of my students did some work on the production of these little jellyfish, and this is at I think this is current pH, and this is increasing pH. No, this is current. Sorry, it's going backwards. Yep. Current pH is here and getting more and more acidic down here. But you can see that there really aren't, there's no differences in what's happening with these jellyfish. So even when it becomes acidic, it's not going to hurt the jellyfish, probably. And this is, you know, this is 100 years from now. It's not anytime soon. What people often do, or always do in their big populations, is that they increase the nutrients in the water. And so it's called eutrophication, and that's nutrient enrichment. And what that does in the ocean is that it increases the amount of food in the water, the plant food, and there's more plants for the animals to eat. And it also changes the food sizes. So that's not particularly an obvious consequence, but the small algae, the small phytoplankton, seem to do well in the eutrophic waters, and so the small zooplankton do well in the eutrophic waters, and they also it leads to low oxygen in the water because there's so much food. It can't all be consumed, and some of it sinks to the bottom and rots. So here is just a schematic of what happens in the water. So here we have what people want. They want the large phytoplankton with large zooplankton that then is eaten by fish. But in a eutrophic system, you get small phytoplankton, the small zooplankton, and the jellyfish don't mind eating that. Jellyfish don't need to see what they're eating. Almost all fish are visual predators. Most of them, even in the deep sea, have eyes for seeing things. And so they do better on large prey. But the jellyfish don't have visual eyes to see the food. They swim around and eat all the time. They can eat all sizes of prey, including the big ones. But so they do fine in these eutrophic systems, but the fish don't so much. The other thing is that the low oxygen also does not bother the jellyfish. And I'm not going to show you any experiments today, but the oxygen levels are getting low. Can you see all these red dots around here? The red dots are where there's low oxygen is a problem in the ocean for people. So it's where people are, in high concentrations of people, and they are causing a lot of low oxygen, and the jellyfish are tolerant of the low oxygen. We basically gave up trying to kill the jellyfish with low oxygen. They can reproduce and everything in low oxygen. But the fish are sensitive to low oxygen, so they will be killed or leave an area with low oxygen. So again, the jellyfish are doing better than the fish. And one of the major causes of maybe jellyfish increasing is fishing itself. And the fishing removes the predators of jellyfish, which people don't really know too much about them. But it also removes the competitors, and that results in more food being available for the jellyfish. So here we have just a reminder of these small fish that are eating the zooplankton foods. And those are being fished out for a fish meal and things like that by people for food as well. So the fish are being removed. Even the small fish are being removed, but really the direct competitors of jellyfish. And here's one of the predators of jellyfish, and I don't know if they occur around here or not. The leatherback turtle, I've always wanted to see one of those. They're one of the biggest marine animals, and they almost eat exclusively jellyfish. It's really quite remarkable. They're actually able to maintain a warm body temperature with eating jellyfish, and they depend on them for breeding. So the turtles actually nest in Malaysia, but they won't nest unless they can get over to the west coast of the United States and Canada or Middle America to eat the jellyfish blooms that occur there. So they get all the energy they need to breed over there. But meanwhile, the fishermen are out with big nets in the Pacific that can catch these things accidentally, but turtles have to get to the surface to breathe. So if a turtle is caught in the net, it often drowns. So the turtles have a terrible problem, and they basically are going extinct in the Pacific. The Malaysians and other people, island dwellers, eat the eggs and the turtles. The turtles get fouled in the fishing gear. They get hit by ships, and then one of the MISE group is working on the plastic pollution. They can eat plastic, and it will kill them eventually. So the plastic in the water looks like jellyfish to them. So poor turtles are having a terrible time in the Pacific, and they're major predators of jellyfish. But there are other predators of jellyfish as well, and I'm not going to go over them all right now. But there are other turtle species, and then there are at least 100 species of fish that eat jellyfish as well. Some of them eat a lot of jellyfish as part of their diets, and then there are even birds that are supposed to eat jellyfish. And I should put a new one on there. I saw videos of at least two species of penguins, if you can believe that also eat jellyfish. I should show that video. That's really pretty fun. Anyway, I never would have guessed that. Anyway, so. Lots of things like to eat jellyfish. Okay, so here we have another cause of jellyfish increases, and this is aquaculture. The aquaculture is increasing around the globe a lot as we're fishing out all the wild fish. And the aquaculture structures add surfaces for the polyps. The aquaculture adds nutrients into the water because most of the the animals they raise don't grow on their own. They need the food to be added to it. And then they have the schooling fish is used to make the food for the fish in the pens. So this is a huge problem. So this is, shows the increasing trend of aquaculture, and as people are removing the wild fish, they are increasing the aquaculture. So agriculture is going to be more and more of a problem, and it is something that needs to be resolved. Another cause of increasing jellyfish blooms is the increased hardening, the development on coastal areas. All of these things are increased shipping, boat marinas, all that, more ships. The ships, all of the big shipping, the oil platforms, wind rigs, artificial reefs, making shorelines. It's all places that the jellyfish polyps and hydroids can grow and increase. So all of these things are increasing at the same time, and as I mentioned, the moon jellyfish are living there. They are. I've encouraged Maya and Ted to go and look at the ports here in town to see if there's some living there. I would expect them to be. The hydroids are also found in those areas. So there's so much to know about jellyfish. It's really an abundant source of study. Almost nothing is known about the dynamics of those attached stages. And here we have still another possible cause of the introductions of the jellyfish increases are the species introductions. And I showed you some boats there. The jellyfish and their polyps can ride on the hulls of the ship as, the polyps can ride on the hulls, and the jellyfish can be actually in the bilge water. So there are jellyfish that have been transported around the world, including the moon jellyfish. And in their wisdom, humans are increasing the capability of shipping. Recently, just in this last year, I think, the Panama Canal has been doubled in size, which is increasing the number of boats that can go through. The Suez Canal has doubled in size. They didn't ask permission. They didn't look at any environmental statements. The Egyptians just made the canal double in size. So the Mediterranean has had a terrible problem with introduced species. Almost monthly you can get a new jellyfish that has appeared in the Mediterranean from the Red Sea. Oops, button. Okay, so we've gone over a bunch of changes in the world that may have caused the jellyfish blooms, and in my opinion, all of these make sense that they could have increased the jellyfish populations. There is no real proof that any of it has, except maybe the species introductions is really, you can't argue with the fact that the comb jelly has been transported from the United States coast over to the Black Sea and has devastated their fisheries there. So there are real flags that go up. Okay, so the environmental damage that may be leading to the jellyfish blooms is increasing. The number of humans are going up and up, and there's nothing to be done for it. I mean, we just have to hope that people get smarter as time goes on. I wanted to show you this. This is not really particularly relevant, except that I wanted to show you a jellyfish bloom. I don't know if any of you have been able to see this, but this is work that I was involved with in Puget Sound in Washington. And each of these white smears is a group of jellyfish. So these are the moon jellyfish that are blooming in Puget Sound. And Puget Sound is heavily populated. These are red tides, the stripes there. Okay, and keep your fingers crossed because we're going to try to do a video. Yeah. This is on the boat. This is a net that I designed for jellyfish. You'll see me over here in the purple. That's me. So this is an aggregation of these moon jellyfish. This is what it's like to go through. The bottom was about 10 meters deep, and the aggregation goes right down to the bottom. So that's where I am. And as it turned out, I didn't need that big net for sampling the jellyfish. A small one would have been fine. So there we are down at the bottom. Anyway, so what can we do? Well, there are benefits. Jellyfish do benefit humans. Even though I haven't painted a very good picture, you can start eating them. Who has eaten jellyfish? Yeah? Yeah? Anybody? Yeah? Okay. Good. Yeah, you. Yes. I know. We know a chef of jellyfish. Anyway, they like to eat jellyfish a lot in Asia, and you probably can buy it here. I can buy it in my little town of Bellingham, actually. And the Asians have considered it very healthy to eat it. It's good. It's filled with collagen, so it's good for your skin and hair and joints. So they're actually very, very valuable fisheries there. And the prime jellyfish, the prize jellyfish species, is more expensive to buy than fish. So then there are also fish that associate with various jellyfish. And for the moon jellyfish, for example, the butterfish in Japan is associated. And when the moon jellyfish have increased in Japan, the butterfish is also increased. So the Japanese love butterfish. It's a very rich, buttery kind of fish. So that's one of the possible benefits, that you can get more fish, some kinds with jellyfish. And then, how many of you are interested in medicine or molecular biology? Who has heard of GFP? Yeah, no, come on, cellular biology. Nobody's admitting to it. This jellyfish won the Nobel Prize in chemistry just a few years ago. And basically, the medical field has been revolutionized by this GFP, which is used in cellular biology to make pathways in cells and things like that grow. So it's a marker. You can also, if you're lucky, buy a pig with a glowing nose or something like that. But seriously, it's really a fantastic, it's an immeasurable contribution. Who knows how many billions of dollars in health. And who has heard about citizen science? Who's a citizen science here? Yeah, everybody should be a citizen scientist. This is from the Barcelona group, and they have a guide for jellyfish. So I think you should make one sort of like this too for the canaries. This animal, the vagega, has been on the beaches this winter. Portuguese man of war, Carabella, is here now. Pelagia is a bad stinger. The moon jellyfish, I still think it could be here. But anyway, these are all jellyfish that could be reported. And I meant to ask from you. You have a website that they can.
Yes, we have Poseidon.
Yeah,
And
Poseidon.
also there is another web which is Chromat.
Okay. So anyway, talk to Mai about getting the local website. But this is a global base. They have reports from all over the world. It's based in California, and it is easily accessible. You can download its app, and the Barcelona group also has an app as well. Oops, wrong. Sorry. Here we go. So this is a picture from an iPhone, and it's very easy to do. And you can report your jellyfish. You can get identification, you can get information, you can get, the Barcelona group has beach information, which beaches have jellyfish there. This one does not do that, I don't think. And anyway, so you can also use these kind of sites to get data that are collected from the citizen scientists. And I personally have written 2 papers from data like that. So it's a good source of information. And this particular picture was taken by a citizen scientist, and it got to be on the cover of a journal. So you can all be citizen scientists and get famous. So that's all I have to say.
If anybody has any questions, okay.
I will be here for 2 more months. So find me up on the 2nd floor of biology, and I'm happy to answer questions or enlist you to do work. So yeah, we've got a good jellyfish team here. Yeah, there's some more of them. Stand up, jellyfish.
I have a question.
Okay.
It's about that paper by, I think it was Condon, in 2012 or something, where they're sort of refuting the idea that jellyfish were increasing in the world, and yet all the data seems to argue that it is increasing.
Yeah, I was part of that group, and I think the Barcelona group got mad at me for actually letting my name be on that paper.
Yeah, I know.
Yeah, what he's talking about is that there's a paper in 2012 or 13 or something that has gathered data from all over the world, but the fact of the matter is that most data is missing from most of the oceans. And so the person that wrote that, Condon, was stuck on the idea that to have it be a global increase or jellyfish increasing globally, it had to be everywhere. And so the jellyfish aren't increasing everywhere. They aren't increasing in the middle of the oceans so much. But they certainly are increasing in the coastal areas where high populations of people live. So I fought very hard, and you'll find in that paper, even though it's kind of hidden and maybe in the lab, deep in the discussion, there is something that says, yes, they might be increasing, but, so yeah, they were stuck on the idea that it was global everywhere. I would say that blooms around the world is a global. So it's all terminology, and that's the fight, the internal fight in the jellyfish world. There's a group that says no, they're not increasing. We don't have the data to say that, and then there's another group which I guess I get included in that group that says, well, maybe we don't have a lot of data, but it's probably happening. I think that in the Mediterranean, there's almost nobody would argue that they're increasing. Do I see a hand over there? No? Okay. Well, why don't you go get some lunch? I want some lunch.
Thank you very much.
Thank you.